So let's go ahead and attempt to solve this system of equations in which x and y are functions of t, and the derivative of x and that of y, they are functions of x and y only. So first what we do is we will rewrite it. Okay, so just in simpler notation, and then likewise here my y prime is x plus 2y, and we can write this in a matrix form in this manner. That is uh, just a moment. Okay, so we have got x prime y prime equals, then we'll create a coefficient matrix from here. Sorry about that. Okay, and that coefficient matrix is, okay, we'll just take the coefficients from here, 4, -1, and then 1, and then 2, and then we got xy. So how have we been doing this before? That is, first step to do will be to find the eigenvalues of this matrix. Okay, so we are going to attempt to find eigenvalues of this square matrix. Now you know that if lambda is an eigenvalue of this matrix, what happens is, okay, is an eigenvalue that will tell us that if we look at this determinant by subtracting lambda from the diagonal elements, what we will get is, we will get a 0, right? So, we are used to this. So here also this minus lambda equals 0, and that will become 4 minus lambda, okay? 4 minus lambda times 2 minus lambda, okay? And so here we are, 2 minus lambda, and then minus -1 times 1, that will become plus 1, and that is a 0. So if we go ahead and FOIL it, what this is going to become is lambda square. Okay, so we have lambda square minus how much? Minus, we got, just a second, I mistyped here, it's 4 minus lambda, so minus 6 lambda, all right. And then we got what we got? We got plus 8 plus 1 equals 0, which gives us this whole, so here we got a 9. And if you go ahead and factor it, it's lambda minus 3 times lambda minus 3. So what it is going to become is lambda minus 3 square. So this time what happens is that we have only one eigenvalue, unlike in our previous example in which we had two distinct eigenvalues. So here what we have is 3 is the only eigenvalue. Okay, so yes, we can write the eigenvalue because here we have only one. Now before we go ahead, let's just settle one thing, or write one thing down. That is, just write an eigenvector for this eigenvalue 3. So if this is an eigenvalue corresponding to 3, okay, to 3, then what will happen is that we will have, if we look at this matrix, after substituting 3 in here for lambda, so we have a 3, 3, and multiply that with uv, then what we are going to get is, we are going to get the 0 vector, right? Okay. And if we, yeah, just rewrite it. So what happens is you get 1 negative 1, and then you get 1 negative 1 again, right? So here it tells us that that we will have many solutions for uv, which we expected, right? So that gives us u equals v. So an eigenvector is going to be of which form? Okay, let me put a comma here. So since u and v are equal, what we have is that we can write this as u, and for v also we can write u, and that gives us what? That all the eigenvectors are multiples of 1, 1. Okay, so here, so what we have is that 1, 1 is an eigenvector of, or an eigenvector corresponding to the eigenvalue 3, right? So this corresponds to 3. So we have one solution here, that is e to the 3t times this eigenvector, or any constant multiple, or any, any real number multiple of this will be a solution. Now the problem is that how do we obtain the second solution? Because we expect two linearly independent solutions here. So this is one solution, and now we are going to look for, let's call this solution, say, let's not worry about calling it anything. So we need a second solution, right? Which should be linearly independent from this one, right? Okay, so solution, that's what we want, okay? And so if you recall from our calculations of the linear differential equations, what worked there was that if we try this, that is say we multiply this by t, then this type of a strategy did work as another solution which is linearly independent from this one, right? Okay, so if we try that, so let us see if this vector, that is, let me rewrite it. Okay, so the vector is this, that is, we are just multiplying both the components with this. So let's see if this is a solution of this system that we are trying to solve. Okay, so here we are. Okay, so we go down here. So what we will do is that we shall just substitute this in here. So this has to actually be equivalent to, okay, where did my let me just write it like this, doesn't hurt. Okay, so first I will write the x prime, y prime. So if we differentiate these, derivative of t is 1, then we get t times the derivative of e to the 3t, which will be the same, right? Okay, so we got e to the 3t, and the second component is the same, so not much to do. So we will just leave it here, and that has to equal. Let me bring it down here because I'm going outside my viewing range. Okay, so this has to equal what? If that is true, for x, what we got? We got this, e to the 3t, t times e to the 3t, and this we got the same for y. So if we go further down, okay, then what happens here after we multiply these guys is that we have this has to equal how much? This has to equal, again, we have simply a 2 by 1 matrix here. So if we multiply, what do we get? 4 times t to the 3t, and then minus, we got this, right? Okay, and then we have in the second row, we got this, and then plus what? 2t, actually 2t to the 3t. So what we got here is this simply, that we have just this term in here, that is which term? I mean, if we go ahead and do the algebra, then we got this 3 times this, and we get the same quantity downstairs, right? Okay, so now you can see that this does not work, all right, because these two are not equal, right? So here we have a, so this just did not work out in the solution, and we can symbolically write it as this, that we got a conflicting result. Okay, so it did not work, all right. But so what we do here is, you can see that the right hand side is this on the right, and but on the left hand side we got these constant multiples of et. So what do we do here is that we try this as a solution. That is, remember this, you took this already, t times e to the 3t, and right, this is what we had taken. So what we are, but we saw this, that we are getting a constant multiples on this side, right? Okay, so what we would do here is this, that to to handle that, let's just try adding a constant vector and see if that will work. Okay, so we have been doing this kind of guesses sometimes. Let's call it a wise guess. Okay, and it's not a, I'm not showing myself as a wise man, just a wise guess. So let's try this. Okay, so if we try this, then what will happen? This quantity is going to be, let me write this as a 2 by 1 vector. So what we will have is t e to the power t, if we just multiply this whole thing out, plus a times e to the power how much? 3t, and here I forgot my 3. Let me write it down. And in this case, it just so happens in this particular case that downstairs we have the same thing, and then we have this. So what we are doing is that we are trying this as a solution. So now what we are doing is we have to determine A and B, and what A and B, what that has to be like is this, that should satisfy this equation, right? So, I mean, there are formulas, but let's just do it in our own ways. We don't need formula for this. So this is x. So if we differentiate this, what we will get is we will get e to the 3t, then as before, plus 3 times t e to the 3t by using the product rule. And here what we shall get plus 3a e to the 3t, right? And downstairs we will get the same thing, because the only change will be that instead of a, we will have a b. I'm sorry, I just did this. So here on the bottom we got this, and then for these guys we will have, what do we have here? We got this here, and then we have this here. I hope that I'm not putting you to sleep, or okay. So then we go further down, and let's just do just a little more algebra, I promise. So what do you get? You get this here. For first of all, let's make sure we got everything right. Looks like we do. Okay, so here we will just bring this e to the 3t here. So that will give us this, right? And I forgot to change it to b. See, just being lazy. That was going to be a b, right? And what we would do here also is that bring this in here. So this will become 3b plus 1 times e to the 3t, right? And here, if we look at this product, what will happen? Here we get a 4, okay? So first we multiply this whole thing by 4, then multiply this by -1. That becomes the first row, right? So here we have negative, and I think I'm moving outside of the viewing area. Okay, let me see. Okay, yep, right, that's not bad then. Okay, and then what do I get downstairs then? Here I get just 1 times this quantity, right? Okay, and then plus 2 times this quantity, right? That's how we multiply matrices. Okay, so 2 and then 2 here. Okay, so what does this whole thing become? And then, of course, this is out of the way now. Multiplication is done. Okay, and now everything is within the viewing area, right? So what we have now is, let's see, this is 3t e to the t minus t, so that becomes a 3, okay? And here we will cancel it. So what we got, e to the 3 is a common factor, so we have 4a minus b times e to the 3t, and then here 2 plus 1 is 3, so we get these. This guy is out, and then what we get is a plus 2b times e to the 3t. This has been incorporated in there. So now if we compare the two sides, these two are the same, right? So here, this quantity has to be the same as this quantity. So what we will have is that we will have 3 to the 3a plus 1 is going to be 4a minus b, right? Okay, so which gives us what? If we do this, just bring everything to the left hand side. negative a plus b equals -1, right? And then here again this and this will cancel, and this quantity and this parentheses have to be the same. So we get 3b plus 1, that equals how much? One moment. Okay, that equals simply a plus 2b. Okay, all right. And this will give us what? Just bring everything onto this side, say for example. So this will give us a minus b equals 1. Okay, and this gives us the same thing if you look at it, or in other words, both these guys give us what do they give us? That a is b plus 1, right? This also gives us the same thing, that a is b plus 1. Okay, so if we look at what this constant vector AB is going to be like, okay, so here is A, here is B, and this can be changed to, for these guys, how? Here we got. So anything that satisfies this will be a solution. So for example, say we just happen to take, say b equals 0. Let's take b equals 0. Then what will happen? AB will become 1, 0, right? Okay. You can take any other choice of that. So for example, take b to be 1, you get 2, 1 there, all right? So, and so on and so forth. So AB is how much? 1, 0. So the other solution, what are we getting for that is that we shall have, this is our other solution, which is linearly independent from, let's get our earlier solution that we had just a little while ago, this one. Okay, so now we have this and this as two linearly independent solutions. No, just a moment. Yes, this was the first one. Okay, and this is the second one that we just constructed in a way that these two vectors are linearly independent, and both of them are solutions of that 2 by 2, that system of 2 by 2 differential, that 2 by 2 system, we can say. So what happens here is our xy now may be written as, so here is xy, right? So we can write it as C1, where C1 is a constant, times this, plus C2, okay, times the other solution, right? So here we are, and we have repeated eigenvalues. So let's look at a phase portrait of this differential equation. And here you can see we have repeated eigenvalues. These are both positive. This portion, x will be to the 3t, y will be to the 3t. So you know x equals y will be a straight line solution. So, so what we have is, like, to sum it up, that this is a general solution, a way of writing general solution of the system of equations that we were looking at. And very quickly, let's go ahead and look at a phase portrait of this by taking up equations for x minus y and x plus 2y at Dr. Nestor's website. So here is the website that we have been using, and I have put the URL in the video description. So what we have here is that I forgot so fast, 4x minus y and x plus 2y. So we have 4x minus y, and then we got x plus 2y here already. So that's pretty good. So you can see here is the slope field and everything, because the eigenvalue is positive and it's repeated. So we have e to a positive number times t. That is a big dominant factor. So things are moving away from origin. And then if you look at this, say for instance, I'm entering a small value so that I can have the solutions fit in here. So remember the straight line solution that I mentioned? Here is straight line solution, and you can go ahead and realize that the solutions are going away from the origin. So in this case, origin is a source, all right? Okay, so, well, this is a way to handle the situation for repeated eigenvalues, all right? So we'll take up the complex eigenvalues in the next video, okay?